Hi, welcome to my video on the order of operations on rational expressions. Order of operations on rational expressions obeys PEMDAS. When simplifying rational expressions which have different operations of addition, subtraction, multiplication, division, the order of operations has to be obeyed PEMDAS. And PEMDAS means we have to do the inside of the brackets first. Then we have to do the powers or exponents. Then we have to do multiplication and division from left to right. Then we have to do addition and subtraction from left to right. So you've seen that over and over. I've reviewed it in fractions, integers, polynomials. So the order of operations has to be obeyed in math all the time. So let's do some examples. Let's simplify each of these. So in PEMDAS, P-E-M-D-A-S, I have to look for, there's no brackets here, there's no exponents here, so that's gone. I have to do the multiplication before I add. So, in that case, let's multiply these two. And in multiplication, what are the rules? Well, in multiplication of fractions, we cancel if we can. That's what I do. So I cancel the x's, and I get 3 over x plus 1. So if I've obeyed the multiplication, division left to right, I multiplied before I added them. Now that I'm adding, subtracting left, when I add fractions, I need a common denominator. And they already have a common denominator, so write down the denominator, which is x plus 1, and I add 4 and 3 to get 7. So PEMDAS, always obey it when you have more than one operation. And again, PEMDAS, P-E-M-D-A-S, or BEDMAS, B-E-D-M-A-S. Either or, whatever one you that you're used to. So now we have to do brackets. We have to do the inside of these brackets first. So I'll write down x minus 2 over x plus 3. And I work out the inside of these. I'm adding. In addition, I need a common denominator, which I already have. So I add up. I get 4x plus x is 5x plus 15. So when I add these two, I get 5x plus 15. Now that I'm multiplying, I have to, in multiplication of fractions, we always make sure that in the expressions, we may have everything factored. If we have all expressions factored, then we can cancel. So 5 is the GCF. So I factor out the 5 and get 5 times x plus 3 all over x minus 2. So now notice I have the inside of the brackets fully done, right to here. Okay, I have no exponents. Now I do my multiplication. So I'm doing my multiplication, and in multiplying fractions, I cancel. So x minus 2 cancels top and bottom. X plus 3 cancels top and bottom. I get 1 times 5 times 1 is 5 over 1, or 5. PEMDAS, always obey. P-E-M-D-A-S-P. Now we don't have any brackets to obey. We don't have any exponents. Now we got to do multiplication, division left to right. So that means I have to do this multiplication and this multiplication before I can subtract. And when we're multiplying, we have to remember we're multiplying these two. So notice that x squared plus 2x has an x as a factor. So I take it out. X minus 3 is okay. X minus 3 is okay. X minus 1. And leaves the subtraction. And I cannot, notice, I cannot factor any of these. So the only factorization I can do is right here. I wrote all that down just to do that factorization first. because when you're multiplying fractions, you have to make sure everything is factored. Now that I'm multiplying, I'll do this multiplication first. So I see the x minus 3's cancel. And that's all I can cancel. Subtract. Because I'm multiplying, I cancel. So the a's cancel. And I get so now I have a common denominator, so I have to make sure that I have to add these together. So what I'll do is, if I'm going to add, I have to make sure my numerators are expanded so I can add. There's no good to leave x times x plus 2 like that. It's expanded out to get a binomial. And notice that I'm subtracting, so I'm going to add on the opposite, because in subtraction I add on the opposite. Now that I have all that done, you can see that I have a common denominator called x minus 1, and I'm going to add these together so they cancel, so I get an x squared minus 1. And the numerator is the difference of two squares, x and x, 1 and 1, plus minus all over x minus 1. X minus 1 cancels top and bottom. So, working out these, you have to obey. After I did the multiplication, which was right here, I have the addition and subtraction. But remember, when I subtract, I add on the opposite, so I never have a subtraction, because I add on the opposite, I'm adding these together, and that's what gives me the common denominator of x minus 1. Okay, a little bit of work, but you get, just think, obey the PEMDAS. Now we have to do obey PEMDAS here, P-E-M-D-A-S. So I don't have any brackets to do, but I do have a power. So no brackets, but I do have a power. So I got to work out that power first. So write this down. So 3 over 2x squared is 3 times 3 is 9. 2x times 2x is 4x squared. So I have the exponent done. Now I got to do multiplication and division from left to right. I have all multiplications, but before I multiply these fractions, I should make sure they're factored. So I see a 2x squared common. That gives me x plus 1. I see a 3 is a GCF, so I factor. Gives me x minus 6. Cannot factor this fraction. X is a GCF. X squared divided by x is x. Negative 6 divided by x is 6. And I have a 1 there, so I'm going to have a double bracket probably. Notice the factors is a 2, so is x and x. Factors of 2 are 2 and 1. Product is negative and the sum is positive, so it must be plus 2 minus 1. So multiply, negative 2, add, plus 1, correct? Okay, can we cancel? Let's see, I got a 2x squared and a 4x squared, so that is once, and that's twice. I see a 3 once, 9, 3. I see an x minus 6 once. Now, do I have x plus 1? No. So the final answer, x plus 1 is not on the bottom. X is not down there. Let's see, so I have a 3 times x times the binomial of x plus 1. And I have a 2 times x plus 2, x minus 1. And can't notice the monomials can't factor. I got an x plus 1, that's an x minus 1. So as far as I can go. Again, obey after when you're multiplying fractions, you make sure they're factored and you cancel. Just a little. Let's continue. More to do. Simplify. Practice. Practice means that you try these now on your own before I do. Look at the problem, write it down, and work it out. When you get it done, press play to see if you get it right. So here we go. PEMDAS. P-E-M-D-A-S. No brackets to do, no exponents to do. I have to do multiplication, division, so I have to divide. So when I divide fractions, I multiply by the reciprocal. So that's multiplied by x minus 6 over 5. So division becomes a multiplication. Because I'm multiplying fractions, I cancel. So x minus 6 cancels. So I get 4x minus 3 over 3. Add on x minus 7 over 5. Now I need an LCD. Because I have multiplication, division done. Division turned to multiplication. Multiplication is done because I canceled. Now I have adding fractions, so I'm down to adding and subtracting. I need a common denominator for 3 and 5 is 15. So I multiply the first one by 5 over 5. Multiply the second one by 3 over 3. That gives me 15. When I multiply 5 by 3, 5 by 4x minus 3, 20x minus 15. 5 times 3 is 15. 3 times x minus 7, 3x minus 21. Common denominator is 15, which means I add up my numerators. And I get 20x plus 3x is 23x. Negative 15, negative 21 is a negative 36. And this cannot factor, because 23 is not a factor of 15. Done. And PEMDAS. Again, I have no brackets. I have no exponents, but I have to do multiplication, division from left to right. So I have to multiply these two first and then these second before I add. When I multiply, I cancel. So the x's cancel out. So I get 2 over x plus 1. Add on. I'm multiplying, so I cancel anywhere, top to bottom when I'm multiplying. So they cancel out, and I get 6 over x. And because I'm now multiplication division is done, I'm going to add and subtract. I'm getting an LCD, which is x times x plus 1. X times x plus 1. That means I'm multiplying this one by x over x. Multiply this one by x plus 1 over x plus 1. So x times x plus 1 is that LCD. And x times x plus 1 is the LCD. X over x, equivalent fractions. X plus 1 over x plus 1. Good. Multiply. X times x plus 1. 2 times x is 2x. And x times x plus 1. Denominators note are the same. 6 times x plus 1 is 6x plus 6. My common denominator is x times x plus 1. And I add, and I get an 8x, 2x, and 6x is 8x plus 6. I can factor out the 2. I see a 2 as a GCF, so take out the 2. I get a 4x plus 3, and an x times x plus 1. But the 4x plus 3 can't cancel. The 2 can't cancel, so I can put an or here. So you could have that fraction right there, or this one, your choice. And again, don't forget, when we're working, simple, we got a subtraction and an addition, and we got brackets. So PEMDAS again, P-E-M. So let's see, we have to do the inside of the brackets first. Common denominator is x plus 3x minus 3. So we leave this one alone for a second. We're doing the inside of the brackets. So the LCD, I have to multiply the first one by x minus 3 over x minus 3. And I have to multiply the second fraction by x plus 3 over x plus 3. But remember, the LCD is x plus 3 times x minus 3. You need one of each of these. So that's 6 over x squared minus 9. Notice we keep going. We're going with the brackets. We're going till the inside of the brackets are fully done. So we multiply. That gives us x minus 3, x plus 3. Multiplied by 1 is x minus 3. Add on. And I get x minus 3, x plus 3. 1 times x plus 3 is x plus 3. And again, we have to keep going until that bracket is fully simplified. And so I have a common denominator of x minus 3, x plus 3. And when I add these, the 3's cancel and I get a 2x. Now, we have to take this, put it right here. Notice that we're subtracting. So these two fractions subtracted. So when I subtract, I add on the opposite. So now I got a better problem to do because I'm adding. And this denominator here is factorable. So that's 6 over. And if you notice, the factorization of this binomial is the same as this. So it's an x plus 3, x minus 3. So I factored it as x plus 3, x minus 3, because that's the difference of two squares. So your common denominator, if you want these two denominators are the same, I could have wrote down x plus 3, x minus 3 by switching that, but it's the same. I know that that denominator is the same as this one. So I'll just write down x plus 3, x minus 3. And I add these, but I can't add, so that's negative 2x plus 6, because I put the x in descending order. And when I get them added, remember now PEMDAS, I have my multiplication division done. I'm simplifying the inside of the bracket. There's no multiplication division, so I'm adding at the end because I add down the opposite. Just review that to make sure I mentioned it. And I see a negative 2 as a GCF. I see a 2, but I never leave a negative in the leading term. So negative 2x divided by negative 2 is x, and a plus 6 divided by negative 2 is a minus 3. Gotta be careful. Easy to make a mistake. And so, let's see, negative 2 times x, right? Negative 2 times negative 3, right? The x minus 3 are same factors, cancel them out. So I get a negative 2 over x plus 3. So again, the order of operations. Notice how it works. But in math, even in calculus, everything works out. You don't have to make difficult problems, really difficult, because they work out good. Number 4. PEMDAS, let's see, PEMDAS. No brackets, no exponents. We got to do the multiplication division first. So let's do this division right here before we subtract. So it's x plus 3 over x minus 4 times x minus 4 over x plus 2. So I'm going to rewrite this one. Didn't have to, but because I did that division first by multiplying by the reciprocal. So now I got to multiply. So that's a multiplication. This is a multiplication. I had to do these two multiplications first. So can I cancel? Yes. When you're multiplying fractions, you can cancel top to bottom. So it's x plus 3 over x plus 2. And this is multiplication here. I cannot subtract yet. I cancel because they're multiplying, so that's subtract 1 over x plus 2. So I have my multiplications all gone by cancelling. I'm now subtracting. So when I subtract, what do? I add on the opposite. And the common denominator is x plus 2. So write down your denominator. And x plus 3, subtract 1 is a plus 2. So x plus 2 over x plus 2 works out to be a 1. So notice the problem works out nicely. Don't have to make it difficult because it's better to understand the order of operations and how they work. So all the review that we did in all the previous videos bring me to this point of simplifying different operations. Number 5, simplify. I look here and I see PEMDAS, P-E-M-D-A-S. And I have to work out the inside of the brackets first. So I have to do this first. But I see 2 fractions being subtracted. So when I'm subtracting, I add on the opposite. So I add on negative x plus 7. So that means because I have 2 fractions with the same denominator, I add on the opposite. X and a negative x cancels out. And I got a negative 3 plus 7 is 4, all over the same denominator. Perfect. So now I have to. So notice so I worked out my brackets right to here. So I added on the opposite, and then I added these up because they got the same denominator. Simplified. I have no exponents. Scratch it out. I have no multiplication division to do. Scratch it out. Now I got an addition and subtraction. So I'm subtracting. So guess what I'm going to do? Instead of subtracting, I'm going to add on the opposite. Add on negative 4. Add on negative 2x. And we'll scratch that out. Make sure it's gone. And make it a minus 7 so you can see it. And I have to factor my denominator in order to get the LCD. And what's the odds? Think about it. Look at these two. They both have a 2 and a 1, just like that. So just check. Without factoring this, just multiply these. X times x, x squared. The last terms, negative 1 times plus 2, negative 2. Let's do the outside. 2. Inside, negative 1. 2 and a negative 1 is 1. So guess what? The factorization, those two multiply to give you that. So therefore, I got it factored. Now you can go through and say product is negative 2, sum is 1, factors of 2 are 2 and 1, and work these out. But notice, if this is going to work, great. One of these two is the factor of this expression, trinomial. So we have it factored. So now we say the LCD is got to be 2 of those, or 1 each of those. And that denominator there is the same as these two, so so this denominator is the LCD. So that means I've got to multiply this one by x plus 2. I got to multiply this one by x minus 1, top and bottom. And I don't have to touch this one. So here we go. So it's an x plus 2 times x minus 1. 3 times x plus 2 is 3x plus 6. Add on x plus 2, x minus 1. Negative 4 times x minus 1. Negative 4x plus 4. Add on. The common denominator, I'm going to keep all the denominators the same. Even though I got an x minus 1x plus 2, then keep them in the same order. And we have a common denominator of x plus 2 x minus 1. And we add 3, negative 1, negative 3. Negative 3x, 10. 6 and 4 is 10. Subtract 7 is plus 3. And do I see a GCF? I see not only a GCF, but I take out the negative 3. Negative 3x divided by negative 3 is x. Positive 3 divided by negative 3 is negative 1. Write down your denominator. So notice we kept our denominator, we added all these up, and then we factored, because I see a 3 is common, but not only 3, but negative. We take the negative 3 out, and the x minus 1's cancel. So the final answer is negative 3 times 1 is negative 3, and x plus 2 times 1 is x plus 2. Works out. And number 6. Again, we do PEMDAS. P-E-M-D-A-S. We have to multiply before we add. And do we have it all factored? In multiplication, we should make sure when we're multiplying fractions that all polynomials are factored. So x squared minus 4 is x and x, 2 and 2, plus minus. 3 is a GCF, 3 and 3x is x, 3 and the 6 goes 2. So because I'm multiplying, I remember now I have no brackets to do, I have no exponents, so I'm multiplying before I add. Multiply and divide. So I got it all factored, so we'll leave this one alone, because I can't touch this yet. I have to work out this multiplication. X plus 2x times 3 is 6x, so 2x goes into 6x 3 times. 3 cancels into 3, so that's a 2x is 3x is 6x over 6x. You see they all cancel out. The x plus 2's cancel out, top and bottom, because you're multiplying. So you get 1 over x minus 2. And so we add, common denominator, keep the denominator, add x, 1 plus 1 is 2. And we cannot cancel the 2's or the x's because we can't cancel in addition or subtraction. So, perfect. Everything worked out. Simplifies really nicely. And one more to do. Practice. Remember, don't forget, pause the video, write down the problem, work it out, and then press play when you get it done. P-E-M-D-A-S. We got to do the inside of each of these brackets first, so we're subtracting, so we add on the opposite. We're adding, so we don't need to do it. So, the common denominator here, the LCD for this bracket is 2x. So you multiply this one by x and x, multiply this one by 2 and 2. And so here we go. That gives us x squared and 2x. This gives us negative 4 and a 2x. So before we go down further, let's deal with this one. So remember, we're doing the inside of the brackets. They already have a common denominator x, so add. We get x, negative 3 and 1 is negative 2. So we have there's no exponents to do, but we have to keep going to get the inside fully simplified. So we got x. So I have to add these. Now I have the inside fully done. I could put the brackets on like that if I want. So now I have multiplication division to do. So I'm doing division. So it's x squared minus 4 all over 2x. When you divide a fraction, you multiply by the reciprocal. Turn it upside down. So we're multiplying. So in multiplication of fractions, I have to remember that I have to factor everything. So x and x, 2 and 2, plus minus 2x times x over x minus 2. So I have it fully factored. Done. I'm still multiplying, dividing. Because I'm multiplying, I have to cancel top to bottom anywhere. So I got an x minus 2. I got an x, and the x goes once, x and the 2x goes 2. So I have x plus 1, x plus 2 times 1 is x plus 2. 2 times 1 is 2. And remember, I'm going to put it just to show you I'm going down. So you cannot cancel here. Now you can't cancel, but you could, but again, divide 2 into both of them, like this. But that will give you x plus over 2 plus 1, or you can just different options. So if you left your answer like that, you could, if you can't cancel the 2, but you can divide the 2 into both of these. Notice that 2 below both, because if I gave you this, you'd say I got a common denominator of 2, and I would add those together. They're there. And since if you want to write it like that, then that's x, that's a 1x over 2, so that's a half x, and that becomes a 1. So this is an answer. This answer here is the same as this. This one is the same as this. All 4 of these are the same. So if you want to leave it like that, or if you want to leave it like that, once you put 2 below both of these, then you have to keep going to either that or that, your choice. So that's simplifying the order of operations: adding, subtracting, multiplying, dividing rational expressions. Excellent to do, excellent review, and ask your teacher for more problems. And if your teacher says, well, we don't do them at this level, well, that doesn't mean to say you can't do them, because the more you do earlier in your math, the better it becomes later. Hope you enjoyed my video. If you did, click the like button, subscribe button, and notification bell, because there's more videos coming your way. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and my content. And that's the content that's on my YouTube channel. Math Fully Explained is the name of my YouTube channel. Thank you for viewing my video. Bye-bye.